Here's how I typically lay out my boards. This is for the front panel of the first contact radio. I use OpenSCAD, which is this tool that allows you to declare script that builds 3D shapes. I'm only really using it in a 2D shape here, although it does have some depth to it, as you'll see in a minute. Yeah, so I just declare my variables. I measure the board, the piece of copper that I've got, and I figure out its dimensions. I have some enables for what I'm going to draw and what I'm going to create to print out. Some little helpers for where things are on the board, where the top is, the middle, and that sort of thing. And then I get down to measuring, for example, the frequency counter, the thing you can see on the left here, this cutout with the screws. I've measured it, and then I've put in some variables so that I can chop that out of the hole there. Out of the board, and then things for where the labels are relative to the holes, and then this is the great bit, right? I can keep these forever. I know that a pot hole diameter for my 3D printer is about 7.5 millimeters, and if I do that, then I'm going to be able to screw a pot through that hole. So once you know the dimension of these mechanical attachments to your PCB, you can always get them right. And if you're not sure, you can print this shape, attach your pot to it, and make sure that everything fits. So yes, and then I start declaring where all my controls are. This is just working out the centers of each of the pots, each of the controls. And then I have some little modules for helpers. I have something that will punch a hole in the plate, something that will punch, this is a rectangle cutout. This is for the text. I'll show you the text. So I made a little tag. This is the yellow background you see here is really going to be the copper plate, but on top of it I'm going to put this tag, and on top of that I'm going to put text. So you can see if I rotate it, the text is actually standing proud. It's extruded over the top, and at the end of this video I'm going to show you what it looks like. So yeah, that's how I procedurally declare boxes. I make boxes this way. I make panels. I find it, as a programmer, I find this a very straightforward way. Yeah, so here's the frequency counter module. It declares the punch cutout, which is the rectangle, and then I walk to the center and I punch holes relative to the center of the square, and I've worked these out based on measuring the actual widget that I got from eBay or Amazon. And then this is the panel. Sorry, the text is quite scrunched so you can see it. Probably isn't as easy to read this way, but I'm just basically walking down, punching holes here, punch a hole for the tuner, punch a hole for the spot control, and then further down I have text, which you can see on the top there. Yeah, so once I've got this tweaked, I'll do a 3D print. It probably doesn't work the first time in terms of the dimensions and where everything is, and I do a couple of iterations, and then now I've got not only something to test all the mechanical components, but I can use this as a drilling template. Also, the tag here with the text is going to be physically on the copper plate, and I'll show that next. Oh, and one more thing. One of the things that I realized once I made this was that it wasn't going to fit on the print bed. Here's the 3D printer, and it was too big. My print bed is 25 centimeters and this is 30, so even rotated it won't work. So I had to add extra magic to the script. I made a little split routine which can draw only half of it, and actually I print this in several different sections, so I can do multicolored text on my printer. But yes, this is the solution. I made the panel in two pieces so that I could print it half and half, and it's quite easy to make some SCAD code that slices off your model in that way. Let me go to the video so you can see what it looks like currently before I drill the copper. And here it is, printed out. The red background will be copper when I drill the copper plate, but it makes a great template for the drilling, and it allows me to test everything and make sure everything fits. And then you can see the text decal there with the text printed on it using my 2-color 3D printer. It's pretty good. And this will be the front display of the first contact radio. I'm all ready to start drilling some copper now.